Hey guys, this is Mr. Hart, and I want to go through in this Livescribe the example problem from slide 3, or the example 3 on the slides 2.8. And I didn't write the whole problem down, but basically the setup is you're trying to give your friend a super ultra high five by running down the hallway. And so the starting scenario is you're 25 meters apart and you're both accelerating at a certain acceleration. You're accelerating at 1.5 meters per second squared, and your friend is accelerating at 1.2 meters per second squared. And we're trying to find the time that it takes for you to meet up, okay, for your super ultra high five, okay. And if you think about graphically what's going on, okay, if we just plot position versus time, okay, this is similar to the flagpole problem that we did before with constant velocities, but now instead of straight lines we have accelerations, which means our motions are going to be parabolic like this. So you will be moving like this while your friend may be moving like that, okay, also parabolic but in the opposite direction. And so we're trying to find this point right here, okay, this time that you meet up at, okay. This is the time we're looking for, and we could also figure out, if we wanted to, the position that you meet at, okay. So if we're setting this up though, you notice that we simply just have to figure out our two motion equations. Okay, so let's think about you. Okay, we'll call you x1. So your position at any time is just simply given by our v naught t plus 1/2 at squared equation. But notice that acceleration needs to be a1 because it needs to be your acceleration, but we can just kind of get rid of v naught t, okay, because you don't have an initial velocity. It's not stated in the problem, but we can assume that, okay. And likewise for your friend, okay, he also has this 1/2 a2 t squared, but he starts away from you. So we're going to set you at the origin at 0, and your friend's going to start at x naught, okay, or this 25 meter distance. Okay, so if you are meeting up, then we know at the time that you meet up that your positions must be the same. So if you are doing the high five, your position must equal his position, okay. So then we just simply plug in the equations and solve. So x1 is just 1/2 a1 t squared, and your friend's position is x naught plus a2, or 1/2 a2 t squared, okay. So if we're solving for t, let's get both of the accelerations on the same side. So I'll minus that over to the other side, so we get negative 1/2 a2 t squared plus 1/2 a1 t squared equals x naught. Okay, let's kind of pull these factors out. We both have t squareds over here, so we could rewrite the left side as t squared, okay, times negative 1/2 a2 plus 1/2 a1, and that equals x naught. Okay, and I could have pulled out the half at that point, but I'm just going to leave it in there for right now. And then we'll just divide to the other side, so we'll get t squared by itself equals x naught over all this stuff, negative 1/2 a2 plus 1/2 a1. And then final step, just square root both sides, and we get that the time is square root of x naught over all that stuff, okay. Now you usually do plus or minus, but we don't worry about negative times for physics, right, because they don't make a lot of sense. So we're just looking at the positive square root, okay. And now we just plug in everything we know. So we get t equals square root of x naught was 25 meters. And now we have to be very careful with our minus signs here, okay. So we have minus 1/2 a2, but we didn't state it, but a2 really should be negative, right, because he's heading in the opposite direction you are. So this will be negative 1.2. So those negatives should cancel out, and we'll get a positive. And then for the other one, we can just leave it as a positive. So just be careful. If you forget that minus, you get a really big answer, because it thinks you're chasing your friend down the hall, because it thinks you're accelerating in the same direction. So we have to be careful and make sure we're doing the negation of the negative so we get two positives. So that should give us square root of 25 over I'll just write it this way. 1/2 times 1.2 plus 1.5, which is 2.7. Okay, at this point I'll plug it into the calculator. Square root of 25 divided by 0.5 times 2.7. And if I did that right, which it looks like I did, to get that the total time is 4.3 seconds. Okay? I'll write it up here again in case I got too low on the paper. I don't know where it keeps track. But there you go. T equals 4.3 seconds. Okay? That sounds about right. So it'll take 4 seconds for you and your friend to meet up and do your super ultra high five. Okay? But hopefully that makes sense, and thank you for listening.